Hello and welcome to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and I am joined by the mighty Suna Withers. We are broadcasting live from the Allan Carswell Observatory located at the Keele campus of York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal Time, York U Observatory. We also run in concert with our online public viewing, or as we call it, the OPV feed, run by the observatory staff. To navigate to our live show or to find out more about us, please check out our website at yorku.ca/science/observatory and follow the link to the online public viewing chat on YouTube. Any questions or comments you may have on past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can also always connect with us on Instagram with the handle at York U Observatory, or on Facebook at Allan I Carswell Ob. All of our programs are free, but if you'd like to make a donation, and we certainly would appreciate that, please see our website at yorku.ca/science/observatory. We will be monitoring the YouTube chat for questions and post content. Between the clouds and some smoke from wildfires elsewhere in Canada, tonight's weather isn't looking too good for observing, so we'll be showing some fantastic archival images on the OPV. Our theme for today is from local to cosmological. Many years before I began to study astronomy, but I was an enthusiastic amateur at that time. Some friends and I would host observing nights for my son's school. Now, this is primary school, so they were I think 10 and 7. But then I remembered the old Monty Python film. Sorry, and during those talks, I was struggling to give what were young kids the feeling for the scale of the universe. But then I remember the old Monty Python film, The Meaning of Life, in which there is a musical piece called The Galaxy Song, which does an excellent job of describing the scale of the solar system, then the galaxy, then the universe, and it does it in 3 verses. So I decided to learn to play the song on ukulele, and it was an instrument I'd never touched before. I found a teacher, and it was the first song we learned. Thanks, Douglas. You did a great job. Now, 20 years later, I still play it and own 5 ukuleles. I find ukuleles to be like telescopes in that you can't have too many of either, although my wife often complains that I have too many of both. I will see if I can find a copy of the video of this song and post it on the podcast webpage. So, Stuna, how are you doing? Are you getting any observing done with all the smoke in the air?
I wish, but no. The last observing we did was actually for the OPV last week, and we had to close down early because the smoke was just not looking great. But one interesting part of the smoke actually is that if you go outside when the moon is out, it looks kind of red.
Yeah,
Not a
yeah,
lunar eclipse, but
yeah.
it does look very red, and it acts as a natural moonlight filter. If you observe the moon through some larger telescopes, it is like blindingly bright, especially through the 1 meter, but
Yeah.
not really through the wildfire smoke, which is kind of interesting.
Well, it's funny. I went out the other night and took a picture of the moon with one of my small telescopes, and yeah, it was red. It actually looked like you were in a lunar eclipse. It was
Yeah,
that red.
yeah,
But yeah, and we get this every year, and I think we're getting it more frequently every year, which is probably a warning to us all. But
yeah.
that may be a topic for a different day.
Yeah, it was a very, very bad 2 years ago. I think that was when
Yeah,
it was even reaching all the way down to New York. There were pictures of people from New York City with this like deep red sky from the wildfire smoke. Last summer wasn't so bad, but I think it's picking up again this year.
yeah.
Not, yeah, it's pretty bad.
Yeah, I feel like I've constantly got a little bit of a tickle in my throat. But
Yeah.
well, on that note, let's get into our show this evening, and we're going to focus on some space history initially that stays pretty close to the solar system. So, Suna, over to you. You've got something on a famous mission.
Yeah. So this is, as much as I love all of NASA's recent missions, I think a lot of the early or not interstellar space, but solar system missions that NASA launched kind of have a special place in my heart because they're just all so cool. So this one in particular is the Pioneer 10 spacecraft, which on June 13th, 1983, became the very first man-made object to leave our solar system. Now, this is like I said, it's a NASA run mission. And like a lot of the early NASA missions of this type, they used to launch them with twin spacecraft. So it's not that they would just launch Pioneer 10 on its own. They had like an extra or like a kind of backup spacecraft, Pioneer 11 in this case, that did somewhat similar things. There are some important differences between the two missions. But the spacecrafts are designed in very similar ways. They have very similar instruments and also very similar science goals. But today we're going to talk mainly about Pioneer 10. It was launched on March 2nd, 1972, with a planned mission lasting only 21 months to go into the outer solar system. But here we are still talking about it today. And the mission itself actually ended up lasting closer to 30 years instead of just the 21 months that NASA had originally planned for it. Now, the Pioneer 10 spacecraft itself had a whole whack of firsts, where it was the first spacecraft to actually accomplish something. First of all, it was the fastest object to leave the surface of the Earth, which which in this case corresponds to around 32,400 miles per hour. That's a bit of a weird number to contextualize, so let me just put it another way, which is if you go to the moon using, I guess, the Apollo mission speeds, it takes you about 3 days to travel to the moon. But it would take Pioneer 10 only 11 hours to travel to the moon. So that's just a reference of how fast, ridiculously fast, this object was leaving the Earth after its launch. It was also the first spacecraft to use 100% nuclear power instead of using solar panels or incorporating some solar panels, at least, like many missions do. It was the first spacecraft to visit the outer planets in our solar system, so Jupiter, Saturn, Uranus, and Neptune. Although it didn't actually visit all of those, it was the first spacecraft to actually hit that region of space and visit that region past Mars, and the first object also to travel through the asteroid belt. This is kind of an interesting thing when you're talking about objects traveling through the asteroid belt, because so many spacecraft have done that today. Any spacecraft that goes past to things past Mars basically has to cross the asteroid belt to get there. And it seems sort of a little bit intuitive now, I think, that it is easy to cross the asteroid belt because we've done it all the time in space travel terms. But at the time, this was actually a bit of a worry that scientists and engineers had about this mission of if something could actually safely pass through the asteroid belt. Put another way, they were wondering if there was actually enough space in between the asteroids in the asteroid belt for something to pass through. It turns out there is. There are a whole whack of asteroids in the asteroid belt, but there's also a whole lot of space in between them. So something can actually very easily pass through the asteroid belt without having to worry about whacking into something and destroying the spacecraft. It was the first ever spacecraft to visit the planet Jupiter, which was, I think, the only planet in the outer solar system that Pioneer 10 did visit. This was a very sort of revolutionary view of Jupiter because it returned the very first up-close images of Jupiter and the first data on its magnetic field. So what that did was it really just confirmed that Jupiter is a gas giant planet. So it's a planet that is pretty much all atmosphere, a massive planet just full of atmosphere without a solid surface to land on, like in the inner planets and Earth. It also confirmed that its radiation belt is about 10,000 times stronger than the Earth's, which is pretty crazy. It was also the first, or most importantly for this this week in history item. Sorry, it's kind of a weird way to put it, but it was the first spacecraft or the first man-made object to actually cross the orbits of Saturn and Neptune, although it didn't actually visit them, and to just go on to leave the solar system. So in this case, when I'm saying leave the solar system, I mean it crosses Neptune's orbit. So it has left kind of what's referred to as the inner part of the solar system, which is around 30 astronomical units away from the sun. There are multiple different ways you can define the sort of border of the solar system, which includes where another way to define it is actually where the influence of the sun's particles, so its magnetic field and the particles that are constantly ejected off the surface of the sun, where that stops having an influence or a strong influence on the surrounding particles. So there's a couple of different ways you can define it. In this case, it's defined as crossing the orbit of Neptune. Now, even after doing that at this ridiculous distance away from the Earth, it did actually continue to send back data on solar wind up until the end of the mission in 1997. Ultimately had its last communication with Earth on January 23rd, 2003, which was many, many, many years after the mission should have actually ended. It's currently headed in the direction of the star Aldebaran, which is in Taurus. It could potentially reach it if it continues on its current trajectory in around 2 million years. So it's not something that we're going to be around to see, but theoretically it is possible that in a very long time it could have it could actually reach a different star, which would be awesome. I do also want to point out that there are now multiple different spacecraft who have actually left the solar system or who are currently on the way out. These include a lot of the other early NASA missions, including its twin spacecraft Pioneer 11, also the Voyagers 1 and 2, and the New Horizons spacecraft. So, yeah, I guess this is a happy anniversary of a bit of a goodbye to Pioneer 10, especially because we are not in contact with it anymore.
Yeah, it was an amazing spacecraft, and there's a couple of other side stories about it. If it ever gets to another star system, it contains a plaque that was actually designed by Carl Sagan and his wife Anne Duran, and they designed this plaque which sits on it, and it's basically a science plaque, although it does have images of a man and a woman on it, and showing their size relative to the spacecraft. It shows the sun's position relative to uh, certain pulsars. It's got a scale, which is scale of the shown of the hydrogen atom. So it's meant to be deciphered. So that was kind of cool, and for a while, NASA was putting things like that on its spacecraft going out of the solar system. Um, the second thing is that there was a problem with the Pioneer's trajectory. So NASA is very, very good at tracking these objects, and they use techniques. They use Doppler from the radio signals and so on, but they can track their velocity and position very exactly. And what they noticed was there was an anomaly in terms of its position and velocity relative to where it was expected to be. Um, and they couldn't quite figure out what was causing it. It was as if there was another thrust operating on the spacecraft. And they dug out the old tapes, and this is something we talk about a fair bit here. There's a lot of data. So they dug out these old computer magnetic tapes, and they were terrified that just putting them in the tape reader would destroy the tapes. They were old and creaky and had worn out. But they were able to extract all the data, and they concluded that the um, radioisotope source they were using in the nuclear battery was actually causing a small amount of thrust, which was affecting the trajectory of the spacecraft. But they worked that out in 2010, well after this was the spacecraft was shut down, and it was quite a controversy. They were wondering, did they miss something? Uh, and as we'll discuss later in this podcast, with science, uh, you often get new data, which you have to figure out how it fits in or change what it needs to fit into. But we'll talk more a bit about that later. One last thing, yes, it left the solar system really quickly. Another spacecraft, which did as well, and it beat this record, 11 hours to the moon, to lunar orbit. The New Horizons spacecraft did it in 9. And the idea there, it had to go a lot further to get its primary mission, which was to Pluto. But basically, you take a very small spacecraft, you put it on a whopping big rocket, and you fire it, and it goes real fast. That was the approach they took both with Pioneer and with New Horizons. So kudos to the New Horizons mission. They you know there are artifacts of us, of people that are now in interstellar space, and it just does not get any cooler than that.
Mm.
But
Yeah.
also, speaking of pretty cool, June 13th, 1993, so 10 years after the 83 leaving, 10 years to the day after Pioneer 10 left the solar system, we're celebrating or memorializing the death of Deke Slayton. Now, Slayton was an incredible person, but he was one of the original Mercury 7 astronauts, and he was the only one of the 7 not to fly on a Mercury mission. And that's a great story in this. So Slayton was a bomber pilot in the Second World War, flying and eventually serving as a trainer within the Air Force or the Army at the time on the B-25. After the war ended, he studied aerospace engineering at the University of Minnesota and then tried to re-enlist in the Air Force at the start of the Korean War, but he had some medical issues. And this theme comes up a lot in his life. Um, so Slayton worked, what he did was he said, well, I want to stay involved. So he went back to the Air Force and said, I'll work in aircraft maintenance until the medical matters clear up. And then they did. And then he served as an F-86 pilot. And then eventually, while he was stationed in Germany, he applied to the Air Force Test Pilot School, was rejected, reapplied 3 years later, and was eventually accepted to become a test pilot at the Edwards Air Force Base. He tested F-101s, F-102s, F-104s, F-105s, and F-106s. He was assigned to the F-102, tested the Matador and Genie missiles, and again tested the tailspin characteristics of the F-105. And then in January 1959, he was selected as one of the candidates for NASA's Project Mercury. This was the first U.S. crewed spaceflight program. He actually wasn't all that interested in space flight, but he agreed to pursue astronaut selection. And after an interview at the temporary NASA headquarters, he underwent physiological and psychological testing at the Lovelace Clinic in Albuquerque, New Mexico, along with 2 other future astronauts, Scott Carpenter and Jim Lowell. In April 2nd, 1959, Lowell was accepted as one of the original Mercury 7 astronauts. Now, later that year, during centrifuge training, they were doing an electrocardiogram on him, and they noticed that he had erratic heart activity. He received further medical evaluation at Brooks Air Force Base and was diagnosed with idiopathic atrial fibrillation, but was considered healthy enough to continue flying. He was assigned to Delta 7, which was the follow on to John Glenn's first U.S. orbital mission. But James Webb, yeah, the same James Webb, who was the NASA administrator at the time, opened an investigation into Slayton's atrial fibrillation. And on March 15th, 1962, 2 months before the launch of Delta 7, Slayton was medically disqualified for the flight. The disqualification status was upheld, and Slayton never did fly in either the Mercury or Gemini programs. This was Deke Slayton. When you're told no, You find something to do to keep you close to the action. So as a result, he became the senior manager in the astronaut office, responsible for hiring the next group of astronauts and crew selection. He resigned his Air Force commission, but remained with NASA in a civilian role, eventually becoming the director of flight crew operations. He developed the NASA model for crew selection and backup crew selection, which was really kind of fundamental to Gemini and Apollo missions and how astronauts were assigned and how crews trained. But while grounded, Slayton took several measures to be restored to flight status, including regular exercise, taking vitamins. He quit smoking, quit coffee, reduced his alcohol consumption. But in 1970, his palpitations became more frequent, and he started taking some experimental daily medication. The treatment was successful, but NASA was concerned that taking the medication would also disqualify him from solo flying. So Slayton stopped taking the medication against doctors' orders. So after a decade of seeing doctors around the world, in 1971, Slayton was examined by the Mayo Clinic, and after a long period without heart fibrillation, was determined not to have a coronary condition. After all that time, and on March 13th, 1972, NASA announced Slayton had returned to flight status. In February 1973, so 11 months later, Slayton was assigned to the Apollo-Soyuz test project as a docking module pilot, along with Commander Thomas Stafford and command module pilot Vance Brand. The American crew began a 2-year training program, which included learning Russian and making trips to the Yuri Gagarin Cosmonaut Training Center in the USSR. He remained in a managerial role throughout the Skylab program and resigned as director of flight crew operations in 1974 in preparation for his upcoming flight. The Apollo and Soyuz spacecraft both launched on July 15, 1975. On July 17th, the two craft rendezvoused in orbit, and the American astronauts conducted transfers with cosmonauts Alexei Leonov and Valery uh, Kubasov. At the end of the flight, an erroneous switch setting caused noxious nitrogen trioxide fumes from the command module's reaction control system thrusters to be sucked into the cabin during crew landing, and the crew was hospitalized as a precaution in Honolulu. During hospitalization, a lesion was found on Slayton's lungs and removed. It was determined to be benign, but he would likely have been grounded from the Apollo-Soyuz test program if it had been found before the flight. He was 51 years old, and this made him the oldest astronaut to fly in space at the time. And that record was previously held by his Mercury colleague, Alan Shepard, from Apollo 14 4 years earlier. Slayton left NASA in 1982 after working on the space shuttle program and then went into private business and continued to do some government work as well. To me, Deke Slayton epitomizes determination. Never give up, stay involved, and keep your eye on the end goal. He really was an amazing man.
Yeah, that story is really insane, honestly. I can't imagine being told no as many times as he was and still actually, sticking it out and sticking around and trying to do the thing that he wanted to do. It's really quite a story.
Yeah, I mean, if you think about it, what he did, he had a methodology, which was okay, you've said no. I'm going to stay as close to this as possible.
Yeah.
And I'm going to keep my foot, maybe even my toe, maybe even just the edge of my toenail in that door and
Mhm.
hope things work out and work to make things work out.
Yeah.
And he did it. He was great. And uh, there was some opposition within NASA to him flying because he was older on the Apollo Soyuz test mission. But Al Shepard, who had taken over as chief astronaut, basically said, We messed around with this guy long enough, let him fly, and he
Yeah.
flew.
I mean,
So
if anyone deserved the chance of, give him a shot to fly, I think it was him.
yeah, I think so.
Yeah.
So
Yeah.
Suna, asteroids.
Yes, yes, asteroids. So this is yet another June 13th. I think this is completely by accident because I didn't try to pick June 13th. But this time, June 13th, 2010, which was when the Hayabusa spacecraft returned the very first samples of an asteroid. Now, this was a mission that was launched by the Japanese space agency, JAXA, which stands for Japan Aerospace Exploration Agency, which had launched in early May of 2003. Now, the primary goal for the Hayabusa spacecraft was to do an actual sample return, the very first sample return of a sample of an asteroid to the Earth so that it could be analyzed up close with the instruments that we have on Earth. Now, if we learned anything from Hayabusa and many of the other missions that actually went to things to explore them, you kind of know that you have to get up close and personal with objects to actually understand them. Observing them with ground or space-based telescopes is great. You can learn a lot from them. But if you really want to get a deep understanding, you're not going to do any better than actually going, grabbing a sample, and throwing all of the instrumentation and everything you have at your disposal on Earth at it to be able to really understand it. So Hayabusa was really wanting to just actually do an asteroid sample return so we could learn more about asteroids and also things like how the solar system formed, and also things like, how did Earth get all of its water that it got? So that was the primary goal for the Hayabusa mission, was to actually do a sample return. It also had several secondary goals surrounding mapping the asteroid that it was visiting, which is called 25143 Itokawa. Itokawa, I think is actually how it's pronounced. But is also generally just a kind of technology demonstration mission. Whenever you do something for the first time, even if the mission doesn't work out, which thankfully Hayabusa did work out, it was a successful sample return. But even if things don't work out with a lot of these early missions, you can still learn quite a bit about how to do it better next time. So, of course, with a lot of these early missions, one of the goals was just simply to, kind of proof of concept, technology demonstration type of mission. I know a little bit more about the target that Hayabusa was visiting, the asteroid. It's a near-Earth asteroid that's kind of peanut-shaped and less than a kilometer in size. So it's a very small type asteroid, which I believe are also very common in our solar system. Now, following the launch in May of 2003, the Hayabusa spacecraft reached the asteroid in September of 2005, where it started out kind of the first part of its mission, which was mapping out the surface of the asteroid. So taking higher resolution measurements of the shape, density, things like that, that it could actually do from a distance and just mapping it out. It later did a couple of test rendezvous or test touchdowns with the asteroid, which were meant to basically do the sample collection of the asteroid without actually doing the sample collection on the asteroid, so that they could test out some of their systems and test out the procedures. During one of these test touchdowns, it deployed a lander called Minerva, which interestingly does tie into a little something we're going to talk about later on. Unfortunately, the lander did not, it was not successful. The spacecraft ended up actually being at a higher altitude than it should have been when it deployed the lander. So instead of the Minerva lander being able to actually, touch the surface of the asteroid, it ended up actually just floating off into space. And nobody really knows where it went after that, unfortunately. There ended up being two attempts to collect the sample from the asteroid a little bit later in November 2005. I am a little bit unclear about exactly when they collected the sample, actually. There were a couple of problems with the Hayabusa spacecraft where it had kind of attempted to do the first sample collection and landing on the asteroid, but there was an emergency ascent that was triggered. So it didn't get to spend as much time on the surface as it had planned, or kind of do a lot of the things that it had wanted. So in this first attempt, it did actually touch the surface, and it did actually land, which became the first spacecraft to make a controlled landing on an asteroid. But then instead of actually doing the sample collection, it just sort of took off from the surface of the asteroid and began an ascent, which in doing so became the first time a spacecraft had ever completed an ascent off of anything in our solar system other than the moon and the Earth. So, pretty significant mission in and of itself. It is possible that some of the sample was collected during this first touchdown attempt because there was a lot of debris and stuff that was kicked up as a result of the landing. These asteroids are small, they're low mass, so the gravitational fields are not very strong, and it tends not to hold on to the material super well in a lot of cases. So even if you do sort of a light touchdown on it, it is very possible you can kick up a whole lot of dust and small particles from the surface of the asteroid. So it seems that there could have been some parts of the asteroid that actually ended up getting collected for the sample return just as part of that initial touchdown. On top of that, it did end up doing a second attempt to collect the sample a little while later, where it may or may not have deployed the sampling mechanism, which is called the sampling bullets, is how they worded it. The data did initially show that they did deploy the sampling bullets, but later on, when upon some reanalysis, it didn't look like they actually did deploy. So I wasn't entirely sure on what date exactly they did collect the samples, but it was in one of these two landing attempts. But either way, they did actually collect quite a good sample, which returned to Earth on June 13th, 2010, and landed in Australia, becoming the very first sample collected of an asteroid and returned to the Earth. In total, they collected around 1,500 grains from the asteroid. I should also note, just in general, that this is a really amazing mission, just partly because the spacecraft had several problems on the way to and back from the asteroid, which included a several months long loss of communication, which was likely due to a fuel leak that sort of kicked the antenna in a direction pointing away from the Earth. So ground crews were not able to get into contact with it. So it's pretty crazy to me that actually months later, after losing contact with Hayabusa, they were able to regain contact and actually return this sample back to the Earth. So this is a really great mission with great, people working on it, that they were actually able to do that. Now, the sample itself was a really amazing sample to work with. It showed that the composition of the asteroid is actually very similar to meteorites, and that it was likely part of a larger asteroid before, separating, or there was maybe a collision when it detached from the main asteroid and became its own asteroid. On top of that, the sample is still being analyzed today, which included some 2021 research that showed that the sample from Hayabusa supports this theory on the origins of Earth's water. Earth has a ridiculous amount of water, way more than I guess would be expected. So there has always been a question of exactly what brought that water to the surface of the Earth and how it got all of that water. And it turns out that just based off of the Hayabusa sample, it supports the idea that all of this water ends up being brought to Earth through things like comets and asteroids. When they collide with the Earth, they end up just depositing some water onto the surface. So the Hayabusa sample has been incredibly interesting. Lots of really amazing science results that came out of it. So I guess this is another anniversary for June 13th for tonight.
And of course, there was a Hayabusa 2, and they're also planning on using the same platform, more or less, to return samples from Mars's moon Phobos. That's an upcoming mission. JAXA is a very interesting organization. They're not as big a player as NASA or the European Space Agency, but they do a lot of really interesting work.
Hmm. Yeah, there's been
Yes,
they've had some lunar missions as well, I believe.
yeah, they have. They have like, and they did a great Venus orbiter as well.
Yes, they've also got a couple, one or two astronauts who've gone to the ISS as well. So they're definitely involved in several different aspects of space exploration.
Absolutely.
Yeah. Yeah.
So it's time for some reminders. We're at the halfway point, a little past it actually. You are listening to York Universe, and we are broadcasting live from the Allan I. Carswell Observatory at York University in Toronto, Ontario, Canada. Please look at our website at yorku.ca/science/observatory to join the chat if you have any questions or want to see some of our current content. Tonight, you're listening to Suna Withers and myself, Paul Mackin. We've been discussing some historical items. And if you're interested in our online public viewing, please navigate to our website and follow the links to join in that fun. We do have a couple of reminders before we get into some news items for the week. As in most weeks, we'll be hosting a live observing, which is weather dependent, in the Arboretum. RSC ran for Recreational Astronomy Night this Wednesday, which is a great opportunity to come out and look through a number of telescopes on the fifth floor of the Arboretum parking garage at Keele campus. Tickets are free, and a link can be found on the website to get them. Donations, of course, are always welcome. On alternate weeks, we mix those up with observatory tours in our main dome, where you can get up close and personal with our 60 centimeter and 1 meter telescopes and hear about the work we do in the astronomy department at York University. These tickets are available the same way as for Arboretum tours, and we alternate between observatory tours and star nights, again on a weekly basis, weather permitting, over the spring and summer months. And soon we have a third event coming up. Perhaps you can tell everyone about our big event later in the month.
Yeah, this is really exciting. It's what's called our open air Astro Fair. It's going to be not exactly run like the normal tours that we're running. It's kind of a bigger event. Instead, it's going to be happening on the first clear day between June 24th to July 4th. So it's a period of maybe like 1.5 to kind of 2 weeks. And we're running the event once on the first clear day from 5 to 11 p.m. on that date. The events, this event is also a paid event. It's not free like pretty much all the other events we do. So if you would like to get tickets to this event, please visit our website at yorku.ca/science/observatory/astrofair. Or alternatively, if you just Google Allan Carswell Observatory Open Air Astro Fair, you should be able to find us as well. When you get the tickets, you'll be put on an emailing list, and we will make the go, no go announcement every day by 9 a.m. So if you do get tickets, please make sure to check your emails to know whether or not the event is a go for that day. I know there's going to be a ton of really cool stuff happening at the Open Air Astro Fair. Some of it will be taking place after dark, so we're going to be doing some observing after dark. We're also going to be doing, there's going to be like a whole bunch of these different stations and booths around. There's people coming from like the Royal Astronomical Society of Canada. There's a planetarium show that will be happening, and admission to the planetarium is included in your tickets. There's also even going to be a really cool display of from the Ice Cube Neutrino Observatory, where they have a scale model, a 1:1000 sort of level display of the Ice Cube Neutrino Observatory. So there'll be something for everyone there. I also feel like I need to promote our James Webb Space Telescope booth. So if you'd like to learn more about astronomy in Canada related to JWST and also the role that York University has played in that, please pay us a visit. We will be selling these really, really cool coasters that Paul, you made. James Webb themed coasters. These things are awesome. So if you'd like to pick some of those up, please come to the Open Air Astro Fair.
Yeah, they're kind of a limited edition thing because they take a long time to print, but I did them on a 3D printer. They're very flashy and quite cool, and they're branded. And anything that goes on at anything that's sold at our swag table, and we have other swag, great T-shirts, shopping bags, posters, and so on. Any of that goes to help fund our observatory operations. But now for some news. So I'm going to lead off on the news tonight with a story, and Suna's going to help me on this because she's more of an expert than I am on the Hubble tension. So to give you a little bit of background, Hubble, the Hubble Space Telescope is named after this guy. And about 100 years ago, realized that the universe was expanding. He looked at the Andromeda Galaxy and identified that there was a star in that galaxy He looked at some other that it was exploding in a certain way, from the way it exploded, he could tell how far it was. He did the same thing on further and further galaxies, and he realized that they were shifted towards the red, which basically means that they're moving away from us. So the universe was expanding. Andromeda, not so much. It's probably coming towards us, but that's a local gravitational effect. But what then happened was, many, many years later, we got a very precise measurement of how fast the universe was expanding. And we suddenly realized that the universe isn't just expanding at a steady rate, it's accelerating, it's getting faster. The expansion is getting faster the further you go away. And this led to, an idea that there's this force called dark energy pushing the universe apart. But then we started to look in other places and saw that, in some older parts of the universe, dark energy seemed to be different than it is now. And this created this idea of the Hubble tension. It's a mismatch between how fast the cosmos was expanding in its youth as opposed to how fast it's expanding today. So, using James Webb Space Telescope information, and that is Suna's favorite instrument, I guarantee it. Using very accurate information captured by it, astronomers have found that the perceived gap between the expansion rate of the old universe and the expansion rate of the current universe is starting to narrow. The expansion rate is measured by Cepheid variables and by the cosmic background radiation. And the way this works is you can measure something and you get a measurement, and then you get an error analysis on the measurement, which gives you error bars. So the idea is, it's X value plus or minus something. Okay. The exchange the rate between the old measurements, the old universe measurements and the new measurements has now come to the point where the error bars are overlapping. And it is really one of the most frustratingly unsolved mysteries in cosmology, right? When astronomers measure how fast the universe is expanding by using nearby stars, they get one answer. When it's calculated from the back afterglow of the Big Bang, they get a completely different number. The gap between these measurements has persisted for a decade, and it survived numerous attempts to get rid of it as experimental error. But now, a new study by the University of Chicago, Professor Wendy Friedman, focuses on measuring the distances to nearby stars and bright galaxies right now. This involved observing exploding stars called supernova, as well as other types of stars like red giants, to calculate how fast they're moving away from us. The launch JSWT, the greatest instrument we've ever launched, probably, it has 4 times the resolution of Hubble and 10 times better sensitivity, has dramatically revisioned our ability to make these measurements. And they've actually started to show that everything's coming in within, the margin of error. So the numbers are a little hard to comprehend, but the universe is expanding at 70.4 kilometers per second per megaparsec. So per 1,000 parsecs through a million parsecs, which is 3 million light years, you get 70.4 kilometer expansion rate for more. It expands at a faster rate. And this has got a 3% margin of error. The new measurement, now statistically consistent with the background, cosmic microwave background, at 67.4 kilometers per second per megaparsec, and that's with a 0.07 percent margin of error. So the first time now we've got this two different approaches that are kind of showing us the same result. Now, Suna, you are some more of an expert on this than me, and you are the go-to person to talk to about the JWST at York. So, any thoughts on this?
Um, I mean, this is a really interesting result and just kind of goes to show, you do things, sometimes just stuff doesn't work out. I know how annoying it can be when you need to or you think you have an intuition for what a certain answer is going to be, but there's some really annoying error analysis that's kind of in your way of getting the answer. It can be very frustrating. And especially that this is a problem that's lasted for like 10 years now, or for possibly even longer than that. It's really sort kind of satisfying to see an actual answer to that, or seeing the tension start to be relieved. Um, but yeah, I notoriously hate error bars. It's kind of a joke between my supervisor and I that if I willingly put error bars on a plot, it's a miracle, but I guess they are very important.
They are, as an undergrad, I can tell you there's one relatively painful course in second year that you have to get through. That's all about error analysis.
You
Although
know,
the textbook is very good.
I know the
But
course you're talking about, and I hated it at the time, but I gotta say
it,
that that has still to this day was one of the most useful courses I took because
but
the error, and you will never escape the error analysis that you learn in that course.
yeah, and this is something that that a lot of lay folks have have struggled with because just because we found an anomalous reading or something that doesn't quite align with with a current model doesn't mean you take the model and throw it out. It means you do a whole bunch of analysis. Okay, and maybe as in this case, you start to find, okay, it isn't that bad. It's within the overlap of the error bars. Okay, we can work with this. Or maybe, and it does happen from time to time, we do have to throw out the model and replace it with a better model.
Yeah, and it
But
also
that is the scientific method.
yeah. Yeah, the other thing is also that error bars in science and astronomy are really everything. Like the measurement doesn't matter if you have like a 60-70% error bar sitting on it. So it's like as annoying as I find the error bars, they are absolutely everything. When you're considering the significance of a scientific result, is you really got to look at the error bars. So this is a very interesting an interesting thing to see. Also, reproducibility, right? It was one team that was working on this that came to this result.
Yes, it was. It was one
Yeah.
team at the University of Chicago.
Yeah.
Now
So
they may be collaborating with others, but from what I can tell, it's just one team at University of Chicago.
yeah. So I mean, given that this was published, I guess fairly recently, there will probably be other people who want to go and do their own analysis of this data. All JWST data is public eventually. So at a maximum, there's a 1 year exclusive access period. And after that, everybody has the data. Um, so at some point or another, there will be very likely some other people analyzing the data, and seeing what they find will also be very interesting. It's not only just the data that you have, but how you process and how you handle the data can also kind of skew your results a little bit. It's usually not like an insane amount, but there are some processing techniques that are better than others. So if you handle things with a bit more care and a bit more precisely, you can definitely get some more accurate results. So it will be interesting to see if there's another team that analyzes this and finds the same result. Um, but that kind of
Absolutely.
yeah,
Yeah.
yeah. But unless you've got any other comments on the Hubble tension.
Not at all.
Uh,
It's over to you.
Yeah, this does actually lead pretty nicely into the next news story, which is also about James Webb and also kind of does have to do with processing data from JWST. Now, this is not a very science-heavy result, but still a very, very interesting or a really great new data release that's come out of JWST from a team called the Cosmos Webb team. Now, it's very common for certain areas of space when you observe it with one space telescope, other space telescopes will follow. So, for example, if, or the vast majority, if not all, of the extragalactic astronomy areas of space that have been observed by the James Webb Space Telescope also have coverage with the Hubble Space Telescope because they're basically just adding to the existing data, which makes their data better overall, basically, when you have data from multiple different telescopes. So there's one field which is called the Cosmos field. It images an absolutely massive area of space. which has now new catalogs and images released as part of the Cosmos Web collaboration. So these are JWST images of what we call the Cosmos fields that were very recently published. Now, just to give you an idea of how much data we're looking at here, if you think of your classic Hubble Ultra Deep Field image where they took the Hubble Space Telescope and they stared at a single patch of sky for days at a time, the James Webb Space Telescope did that, but much, much wider. So if you were one of the principal investigators of the program gave the analogy where if you printed the Hubble Ultra Deep Field on a standard size piece of paper, the Cosmos Webb observations relative to that would be 13 by 13 feet. So this is an absolutely massive area of sky that the James Webb Space Telescope has imaged, but with very similar sensitivities to what the Hubble Space Telescope observed in the ultra deep field. So in total, there is 800,000 galaxies that appear in this patch of sky, which corresponds to galaxies existing over 98% of all cosmic time. The most distant galaxy in their sample existed when the universe was only 13.5 billion years ago, which is only around a few hundred million years after the Big Bang, since the universe is 13.8 billion years old. So tons of galaxies across a vast area or region of cosmic time, vast area in space as well. So they're able to basically look at the very large scale distribution of our universe. Things in our universe are not distributed evenly. There are areas that are very dense where you have lots of galaxies like galaxy clusters or galaxy groups. And then there are also different areas which have massive voids. So surveys like this, like Cosmos Web, really give you an idea of these larger scale structures, the environments around galaxies, and also can help to find some very rare, very interesting sources that you wouldn't typically see if you're looking at a smaller patch of the sky. Now, one of the really great things about what we're talking about today is that not only have these astronomers taken the data with JWST, they've also done very detailed processing of this data. So they've basically releasing a whole bunch of catalogs and stuff of, images that were processed very well, and catalogs that really anybody can use. The data is all public now. They've released their own reductions. So if you wanted to kind of play around with data from Cosmos Web and some Python, you definitely can play around with it. It might be a little bit of a learning curve, but the data that they produce is really great. So you could kind of play around if you have some Python and AstroPy skills with this great JWST data. And the other thing I do also want to mention, because I can't stop talking about it, is that York University is going to be getting more data on this exact field coming, I think next year or the year after, using data from the Minerva program, which is going to give some even more detailed observations of these 800,000 galaxies. So this is kind of crazy. 800,000 galaxies is a lot. Really crazy to think about having that many galaxies in an image. So there'll be lots of really interesting science having to do with galaxy evolution and how early galaxies formed in our universe that can come out of this.
And I have a friend who is very well connected with this particular program and has lots of observing time, but she will remain unnamed, won't she, Suna?
Yeah.
Um, but now, forget the wildfire cough there. Now we're heading back to the local and linking. Oh, you did mention one thing. You mentioned Python, the programming language, and Python, of course, the programming language, very great language. We use it a lot, but it was developed and named after Monty Python. So I'll just put that plug in there as well if you're a Monty Python fan. So the next thing I'd like to talk about is kind of a follow-up to what Suna was talking about with JAXA, because the other country that's doing a lot of interesting work with sample return is China. They have returned samples, for example, from the far side of the moon. No one's done that before. They're planning a Mars sample return mission, and given a fair bit of uncertainty with the U.S. space program budget right now, they might beat the U.S. on that. But they've also launched what I consider a really fascinating mission, and it's one of those things that I sort of asked myself, why hasn't someone done this before? So occasionally, Earth gets another moon. And it isn't really a moon, it's a quasi-moon. Earth has them, Venus has them, we think. We found at least one for Venus. But these are asteroids, near Earth asteroids, that come very, very close to the Earth, but they're not going to hit it. But they kind of go into a quasi-orbit. They'll travel along with the Earth. They'll maintain a relatively constant distance, kind of in a horseshoe pattern, and they're pretty far out. They're a lot further out than the moon, but we get these from time to time. And to my mind, it was always like, well, why don't we send a sample return mission, or at least a reconnaissance mission, photographic reconnaissance mission? Take a look at these things, because they're not that far. It should be a relatively easy mission to manage. And no one's done it, but now China has done it. So China has successfully launched a spacecraft as part of its first ever mission to retrieve pristine asteroid samples. That's their first attempt to do an asteroid sample return. And they're aiming for, it's the TON 2 spacecraft. And if they are successful, they'll be the third nation after Japan, who's done it twice, and the US, who's done it once, to return pristine asteroid rocks. They announced the launch. The spacecraft has unfolded its solar panels smoothly. They're circular, like another mission, like the Lucy mission to asteroids out near Jupiter. And they're going to approach this small near-Earth asteroid, which is about 16 million kilometers away. And it's got this great, charming name, which I'm completely going to mangle: 469219 Camo Olawea, which is also known as 2016H03. You gotta love the naming conventions. But the spacecraft is scheduled to arrive at the astronaut, which people think might be a fragment of the moon, a little over a year from now, July 2026. It will then shoot the capsule rock samples back to Earth, landing in November 2027, and then it will go on to look at a comet. So they'll be the third to do this, and then Japan is going to follow up with a mission uh, to Phobos to do the same thing there. But it shows you how other nations are starting to advance. China's becoming a real leader in certain robotic spacecraft. That, of course, they have a manned program. They've got their own space station. They're becoming a real powerhouse in space exploration. What do you
Yeah.
think, Suna? What you looking to get your hands on some samples?
It's not. I'm a galaxy person, so the samples are awesome, but I will let someone else do the analysis and then read about their cool results after. Um, but yeah, this is I'm really looking forward to this. I know this wasn't necessarily the exact topic you were talking about, but the sample return from the far side of the moon, that's going to be a really interesting thing to see. I mean, it's the moon, it's very close to us, but we still haven't actually gotten samples from the other side of it. And I know even in the Apollo missions, depending on exactly where you landed, even on the near side of the moon, you would sample different parts of lunar history and learn different things about the history of the moon and its composition. So that could also be a very interesting thing to see is what the far composition of the far side of the moon is.
Yeah, and of course you're highlighting an important point that we do specialize in astronomy and astrophysics, and I'm nowhere near deciding what I'm specializing in, but I got to admit I like asteroids. I really do. I got one. I got one in my office, a little one. But with that note, we're at time. So you've been listening to York University Astronomy and Astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Suna Withers and myself, Paul Mackin. This podcast and past episodes are available wherever podcasts are distributed. You can also always connect with us on Instagram with the handle at YorkU Observatory or on Facebook at Allan I. Carswell Ob. Our website is yorku.ca/science/observatory. And there we have a lot of interesting contents. And if you feel so inclined, it's a great place to make a Canadian tax deductible donation to our student operated, not for profit observatory. And of course, you can also come to Astrofest. Those funds will go to the same place. And hey, maybe you could buy some Hubble themed freight coasters with a very nice branded York University Allan I. Carswell Observatory holder for them. So thanks for tuning in this evening. We wish you clear skies and good night.
Good night.